Hello and welcome to the Geomistic channel. Today we're going to talk about congruent polygons. Hey, if you haven't already, there is a link to some guided notes down in the description. Check those out. It might be helpful for you to write down some things while we go. So you've likely already learned what the word congruent means. We know the symbol for congruency is this little guy right here. And congruent just is a fancy way of saying two things are the same. Now congruency is probably one of the more important concepts in the geometry world. And today we're going to talk specifically on what it means for two polygons to be congruent to one another. So congruent polygons are two polygons. In this case, I'm going to use some rectangles. And congruent polygons are polygons that have congruent corresponding sides and angles. So all their parts are the same length, same measure. So in this case, we've got a rectangle here. We'll call it ABCD. And then a second rectangle that is WXYZ. Now, in order for these two polygons, these two rectangles to be congruent, all their corresponding parts must kind of map onto one another. So I can map one of these figures exactly onto the other figure with some kind of a transformation, like a translation, or reflection, or rotation, or you might have seen these as slides, flips, and turns. But I need to know that all their parts are the same. So we have some notation. You've likely seen this before as well. So if I put a little tick mark on a segment, and I put a second tick mark on another segment, that denotes that those two segments are in fact the same length. So I can say that segment AB is congruent to segment WX. So if I want these two polygons to be congruent, I would have to know that all four pairs of corresponding sides are in fact the same length. So two tick marks matches onto two tick marks, three tick marks to three, and then 4 to 4. So I now know that all four sides of these two rectangles are in fact congruent. It's not just the sides, it also has to be the angles as well. So if two angles are the same measure, you'll see this notation of a little arc in the corner. So angle A is congruent to angle W. And then if I just kind of go around the horn here, angle B is congruent to angle X, C congruent to Y, and then D congruent to Z. So with this information, I now know that all four sides, all four angles are congruent to one another. Thus, I can make the conclusion that figure ABCD is congruent to figure WXYZ. So a common question that you might be asked is to consider or determine whether or not two figures are congruent, and then justify why you think that that's true. Now, at first glance, that may seem pretty easy, relatively simple and straightforward, but what you'll find is these questions often leave out necessary information that you'll have to kind of extract out of the situation. So before you can make an accurate decision, you kind of have to go through a few things. So before we get into some examples, here's a few things that you can look out for. So the first thing is a situation whenever two lines cross, you get these sets of angles. They're called vertical angles. Vertical angles are angles that are opposite of each other when two lines intersect. So if I give you some points here, call this A, B, C, D, E. So vertical angles, again, whenever two lines cross, opposite angles, so for example these two, so angle ABD and angle CBE, those would be considered vertical angles. And also ABC and DBE would be considered vertical angles as well. So ABD, angle ABD, and angle CBE are what we call vertical angles. Vertical angles. Now the nice thing about vertical angles is in this situation, vertical angles are always the same measure. So vertical angles are in fact congruent. So even though these two angles aren't necessarily marked as congruent, when I see that situation, I know I can go ahead and mark those two angles as the same measure. So vertical angles are always congruent. The next concept you might see a lot is whenever two figures kind of map up onto the same side. So for example, So you've got these two figures that are back to back, matching up on this side here in the middle. So the thing about this, if I were to take these two figures and kind of slide them away from each other, I know that this segment here in the middle, this segment BE, because they both share that side, I can say that that segment is congruent to itself. So if I'm trying to figure out if the four sides of these two figures are the same, I really already know that this segment in the middle is the same because they share it. This is called the reflexive property. So if I know that segment BE is congruent to itself, because they share that side, this is an example of what we call the reflexive property. And you'll see the situation happen a lot. You can always mark that side in the middle. Okay, a third situation that you might see is kind of a similar situation where they're backed up next to each other. Maybe there's some information that's given to you that says that B is the midpoint of segment AC. B is the midpoint of segment AC. So if you know what a midpoint is, it is exactly what it sounds like it is. B is the middle point halfway in between points A and points C. So what does that tell us? That means that this segment here, segment AB, and this segment here, segment BC, have to be the same length. Okay, so those two segments right there would be considered congruent to one another. So without that given to me, if I have that information, I always know that those two segments, if you have a midpoint, two segments are going to be the same. Okay, there's a segment that gets cut in half. The last thing to look out for, and then we'll move on to some examples, is to look out for parallel lines. So parallel lines are lines that never intersect, that are in the same plane. So parallel lines are denoted by two little red arrows. And you've learned likely that whenever two lines intersect, you get a bunch of angle pairs, many of which happen to be congruent to one another. So I'm going to extend these lines out a little bit just so you can see what I'm talking about. So if I extend these lines right here, you've got two parallel lines cut by a couple of different transversals. And if you remember, whenever you have a bunch of angles at these intersections, you have things like alternate interior angles or alternate exterior angles. And if you remember those are congruent. Those angles are always the same. So whenever two lines are parallel to one another, you have a transversal that cuts through. I have these things right here, angle 2 and angle 8. Those are alternate interior angles, and alternate interior angles are always congruent to one another. Okay, so without that information given to me, like they don't have arcs in the corners of those angles, I can determine that those are the same based on those lines being parallel. Okay, so those four different examples there of some things to look out for when you're trying to determine whether or not two polygons are in fact congruent, because it's got to be all the parts. So let's take a look at an example here. So we got here. We'll switch it up. We'll go Z, W, X, Y. And we'll put in some information. Let's say you got some tick marks and you've got some angles marked as well. Okay. So let's say that our question is to determine whether or not these two triangles, so triangle ZWY, triangle XWY, we want to know if those two triangles are congruent to one another. So based on the definition of congruency in congruent polygons, we need to know that all the parts, all three sides, all three angles of each triangle are the same. Luckily, we are given some information. We know that there are a certain number of sides and angles that are already marked as congruent, which is nice. But not all three sides and not all three angles are marked congruent. So we have a little bit of work to do. Now to answer this question, we're going to kind of structure this in a way that you're going to see relatively often when you're talking about congruent figures, and that is to set it up as a two-column proof. Two-column proof. This seems like a lot of work, but it's just a good way to organize your thoughts and to get things written down in a way that's easy to read and easy to follow. So 2 columns here. On one side, we're going to have some statements. And the other side, we're going to have the reasons why those statements are true. So statements on one side, the reasons those are true on the other side. And when we get finished here, we're going to have a systematic way of laying out how we know for sure to justify our answer whether or not these are congruent. So to start, we're going to start with things that we know for sure are true based on the picture that we were given. Let's start with sides. So first of all, we have some tick marks. In this case, we know definitively that segment ZW is congruent to segment XW. How did we know this was true? Well, because they told us it was true. So we have tick marks on those two sides. Anytime you have information that's been given to you at the beginning, the reason it's true is because it was given to us. So we write given. That's true for another pair of sides. You can see the 2 tick marks here and here. So I do know that segment ZY is congruent to segment XY for the same reason. Okay, so we know that 2 pairs of sides are the same, but that doesn't cut it when we're talking about congruent polygons. We know that we need to know that all 3 sides are the same. So what is the third side of each triangle? Well, it's this side right here in the middle. And what we talked about before, anytime 2 triangles or 2 figures share a side, in this case, it's this side right here, right in the middle, ZY or WY, we know that those sides or that side in the middle is congruent to itself based on that reflexive property. So we can go ahead and mark that middle side. It's always important to mark what you know. We mark that middle side, WY, as congruent to itself. So WY is congruent to WY. And the reason we knew that was true, it wasn't given to us, it didn't have marks on it at the beginning, but we know it's congruent to itself by the reflexive property. Okay, so there's all 3 sides we know now. All 3 sides are marked congruent. That's a good start. It's not just the sides though, we also need to know that all 3 pairs of angles are congruent. Now again, we're lucky enough to have some that are marked congruent, so we don't have to do any work there. We've got angle Z and angle X over here. We know that those 2 angles are the same. They've got an arc in each corner, so angle Z, congruent to angle X. Why is that? Arcs in the corners, that's given. We've got another pair of given angles, and they're up here at the top. Now in this case, we could say Z and X, angle Z and angle X, and we could use just the single letter because there's only one angle at that vertex. But up here at W, we've got really 3 different angles. We've got this angle here, we've got this angle up here, and then we've got the whole thing at W, which is its own angle with those 2 together. So we can't just say angle W in this case because there's lots of angles there. So to specify, we're going to use the 3-letter method to name these 2 angles. So let's start with ZWY, that's this angle up here on the left. Angle ZWY is congruent to, and then this angle here on the right, XWY. Clean that up a little bit. Nope, try again. Congruent to. There we go. So angle ZWY is congruent to angle XWY. These 2 up here, once again, because they told us with the arcs there. So that's given as well. Okay, so now we're down to one more pair of angles, which we need to have marked congruent to be able to say these 2 triangles are congruent. Unfortunately, we do not have markings in the corners of there. So we can't just say that it's true because it's given, because it's not. But if you think about a triangle, you've probably learned this in the past, that the measures of the angles in a triangle always add up to a certain number. So no matter what, the angles in a triangle always add up to 180 degrees. So if we think about this numerically, if we actually put some numbers in there, whichever numbers we want, it doesn't really matter necessarily, but if we just made up some numbers, let's just make up some numbers real quick. Let's say that this angle up here was 80 degrees, which also means that this angle over here, because those are congruent, would also have to be 80 degrees. Now, is it 80? Probably not. We're just making it up for a minute. So if that's 80, and let's say that these two angles over here were both 40 degrees. So these two angles being congruent, they're the same. Let's say they're 40. Now, if we were to solve this problem as figuring out the third angle in the triangle, we would just add up the two angles that we know, 80 and 40, which if you add 80 and 40, you get 120. So 120 degrees, and I subtract that from 180, which is the total of all three angles added together. I know that that third angle would have to be 60 degrees. Okay, right here, that would have to be 60. But because these two angles are the same as those two angles, well, that would have to be 60 as well. So that would make that 60, that would make that 60. And the thing is, regardless of what angles, whatever measures I pick for these two angles, they would have to be the same as these two angles because we already know they're congruent. So if I have two angles in one triangle that are congruent to two angles in another triangle, that forces those third angles to be the same as well. Regardless of what the numbers are, that third angle in each triangle would have to be the same. Okay, so I've seen this called the third angle or the third angle congruency theorem, something like that. Just know that if two angles in one triangle are the same as two angles in another, those third angles are going to be the same. Okay, so based on that information, we're going to go ahead and finish this out by saying those third angles, angle 6 or number 6, these two angles, I should go red here. We're going to mark those two angles congruent based on that third angle theorem. So we'll say ZYW, this angle here on the bottom left, angle ZYW is congruent to angle XYW. And the reason, we're going to call that the third angle theorem. I'm going to abbreviate a little bit. Third angle theorem here. Okay, so you see what we have? We've got all three sides marked congruent. Here's the sides. We have all three angles marked congruent. Here's the angles. So based on the definition of what it takes for two polygons to be congruent, we have here essentially proven that these two triangles are in fact exactly the same. They are congruent to one another. So to finish it off, we'll go ahead and make that final statement. We'll say that triangle ZWY is congruent to triangle XWY. And how do we know? We systematically proved by stating that all three sides and all three angles are congruent, which is the definition of congruent polygons. So we'll say that is the definition of congruent, we ran out of space, congruent polygons. There we go. Now again, seems like a whole lot of work for one little statement of saying yes, they're congruent. But the good news is we're going to get some shortcuts. Specifically for triangles, there's kind of some quicker ways to do it. But for now, this is good enough. So we've got all three sides, all three angles. That forces these two triangles to be congruent to one another. Okay, we're going to get one more example. We won't go through the whole rigmarole of the two-column proof on this next one, but we'll still kind of systematically go through each step. Okay. So for our last example here, we're going to have two triangles that kind of look like this. I'm going to give you another statement down here. You may have seen this one before. We're going to say B is the midpoint of segment EC. I'll give you some other small pieces of information here in the picture. So I'm going to give you some segments and some arrows there. Okay, so the question is the same. I want to determine whether or not these two triangles here are congruent. And you notice I give you a whole lot less information than I did with the first example, but does that mean that these are not congruent. Well, not necessarily. It just means we have a little bit more digging to do to figure out these missing parts. So once again, it's always best to just start with what we know. We already know that one pair of segments, AE and CD, we know that those two segments are the same. I've got the tick marks on there. So I've got one pair of congruent sides, but I've also got these arrows, which again, if you remember, that means that those two sides are parallel to one another. And what you look for with parallel lines, if you remember, things like alternate interior angles that are congruent. We're going to see those here in a second. So let's do that. Let's go ahead and start there. So we've got two lines, and I'm going to, again, extend this out so it kind of looks a little bit more familiar. So two segments. In this case, these two segments here are parallel to each other. And I've got these two lines that extend out, and I've created the system of parallel lines and some transversals. So in this picture, we've got these two lines being parallel. I'm going to use this segment CE here first, and I've got these two angles, which are in fact alternate interior. They're on opposite sides of the transversal. This angle is above it, this angle is below it, and they're interior in between the two parallel lines. So these are alternate interior angles, which we know again are always congruent to one another. And in fact, if I look at this line, AD being the transversal, I really have two pairs of alternate interior. So again, parallel lines, these two angles, opposite sides of the transversal, in between the parallel lines, those are alternate interior as well. So with those alternate interior angles, I've got two pairs of angles now that are the same, which is good. We only need one more pair of angles to get all three. So where's the third pair of angles? Right here. So angle ABE, angle DBC, these two angles in the middle, that should again look familiar. Those are the vertical angles. Two lines intersect, angles that are opposite of each other. Vertical angles are always congruent. Okay, so we went from having no angles marked congruent to all three angles marked congruent pretty quickly with just some quick properties and definitions that we've learned in the past. So all three angles are congruent to one another, vertical angles here in the middle, alternate interior angles for the other two pairs. So again, good start, all three angles. Now let's move over to the sides. We've got one pair of sides marked already, but we've got this information here we haven't really used yet. So it says B is the midpoint of segment EC. So let's think about what that means. B, right there, B is the midpoint of segment EC. What does that tell us? Tells us that B is halfway between points E and C, meaning this segment here, segment EB, this segment here, segment CB, must be the same length. Okay, they're equal in length. That means those two segments are congruent. We're down to one last part. One last part is a third pair of sides, which are here, AB and DB. Now, are they congruent? Is there anything else in this picture that we can use to kind of get that information? B being the midpoint of EC, does that also mean that B is the midpoint of AD? No, not necessarily. Doesn't say that. So dang, we are 5 in, we needed one more piece, and we don't have it. So what does that tell us? Unfortunately, we do not have enough information at this point to say that these two polygons, these two triangles, are congruent. So with what we know as of right now, 5 out of 6, it's not enough. Not enough. You got to have all 6 parts, and if there's no way of knowing that you have all 6 parts congruent, unfortunately that's just not enough information to say that these two triangles are congruent. Now, might they be? Sure, they could be, but do we have enough information at this point? And the answer is no. Okay, so I cannot say, I can say, we'll just do this. We'll say triangle ABE is not necessarily congruent to triangle DCB. Okay, we just don't have enough information at this point to say that those two triangles are congruent. Now, if you've worked ahead and the terms SAS and ASA and AAS, if those ring a bell, then you're like, yeah, of course these are. But we haven't got there. So those little shortcuts, that's going to be covered in the next video. So at this point, not enough information. Stay tuned. You're going to get some really nice shortcuts that are going to make things a whole lot easier here in the next lesson. So, congruent polygons, all the parts, all the sides, all the angles have to match up and be congruent to one another in order for two polygons to be congruent. That's all we have today. Thank you so much for watching. Again, the guided notes in the description. If you need them, they're helpful. If this is helpful to you, give it a little like and share it with somebody that you think it would be helpful for as well. Thanks for watching.